will be a recording of this event. Let's just wait for 2 more minutes and then we'll start. Okay, let's start with the session. So, welcome everyone to this workshop on building on Zilliqa. The target audience for this workshop is technical founders and developers. In this workshop, we have three speakers: myself, Arnav, Amrit, and Anton. So the first session will be taken by Amrit, and the second session will be taken by me, and the third session will be taken by Anton, and the final session will be again taken by me. The and the sessions are designed in such a way that the difficulty increases technically. So the first session is on an overview level, then we have an overview of Scilla, or an overview, and then we go deeper into Scilla. Then we finally learn about Zilliqa JS and building a full stack application. Also, people have a chance to earn a certificate by completing some quizzes that we will share. So we will share a quiz after each session. And if you get 50% on all the quizzes, you'll get a blockchain certificate, and we'll send that to you by email. So you can show that to say, add that to your resume and share that with other people. Also, the quizzes have some reward mechanism, so we'll be rewarding people who come in some top ranges. So top 10 people for each quiz will be rewarded with some Zil. Pay close attention, and yeah, I hope you learned something. The format of the video will be of the sessions will be that we'll have say 30 minutes for talking about the content of the session, and 10 minutes for um, answering questions, audience questions. And the quiz link, as people are asking, will be put to in the Zoom webinar chat. And if we are going to put, we are also thinking of putting on the Eventbrite page, so you can check that out as well. But it will definitely be put on the Zoom chat. So for the first talk, I'd like to introduce Amrit, who is the president of Zilliqa, and he'll be giving an overview of Zilliqa. And yeah, okay, up to you, Amrit.
Thank you, Arnav. Hello and welcome everyone who have joined this session. So the first session is going to be, I would say, the least technical one. The goal of this session is to give you a very high-level overview of what Zilliqa is, what are our offerings, what we're trying to achieve, and both on the technical side and also on the non-technical front. So in terms of adoption, in terms of building an ecosystem around Zilliqa. So this is all that we are going to cover in the next 30 minutes, roughly speaking. So let me get started with this. Okay. Okay, hope you can see my slides. Okay, so let me start. So Zilliqa, as let me just check, someone sent a message somewhere. I think everything is okay. So Zilliqa, as some of you may know, is a blockchain platform similar to Ethereum. So it provides developers and anyone who wants to build decentralized applications a platform on which they can build their applications. And it's an open platform similar to any other blockchain platform that you see today, in the wild. So today I'm going to give you a very high overview of what Zilliqa is, what we're trying to offer, and our approach towards what we call open finance with Zilliqa. So when we started Zilliqa, it was back in 2017, so early, I would say June 2017, when we started to think about what we can do in the blockchain space. So back then, I personally was a researcher at the National University of Singapore, which is a university well known for the academia. And this is where I was working on how to, this was basically I was working on scalability and privacy for blockchain infrastructures. And around that time, we had seen incidents like CryptoKitties happen. We had seen incidents later on, we had seen incidents like DAO happen. And this is where we try to understand what is that this blockchain space actually is missing right now. And one of the biggest problems that the blockchain space was facing back then was around scalability. So the chains that were around this, especially Ethereum, was only able to process around 5 to 10 transactions per second. And so there was a huge lack and huge gap between what an emerging technology like blockchains had to provide in terms of capacity and what real world applications such as even a payment infrastructure would need from a real world in a real world setting. So we started to work on that, and we decided to develop a blockchain infrastructure that could scale in the real world. And at the same time, we're also looking at this problem of smart contract vulnerability. So we are seeing attacks happening on and vulnerabilities being found on smart contracts. So we had bugs like that happened with DAO contract, for example, where a substantial amount of Ether was stolen from a contract, and which resulted in Ether and Ethereum Classic. So we're also looking at how to make sure that those incidents don't happen in the future. So to make sure that we can define and design a language that can be safe for people to use and safe for people to put substantial number of assets, valuable assets in that contract. So over the time, once we have developed this, the vision was to be able to build a platform that could allow sort of building of open finance platforms. So what I define by open finance is basically a layer of finance that are interoperable. So in some sense, once you have an application like, let's say, insurance, it can talk to your banks. Once you have a lending borrowing platform, it can talk to your insurance platform, for example. So a lot of these applications that you see right now, even in the traditional financial space, could be brought down towards blockchains, and that by the virtue of what blockchains provide, you would have a platform that allows dApps to talk to each other in an open and transparent manner. So with that vision, we first had to look at how to make sure that this whole vision can be built. So there are three approaches to this, three parallel approaches to this that we had to take. The first one was to be able to build a platform that can support, the robustness that real-world applications would require. So a platform that's scalable, a platform that provides developers a safe environment to write their contracts and safe environment for users to interact with those contracts as well. The second was to be able to provide products built on that platform that people could make use of. And third was to be able to provide an environment for developers, miners, enthusiasts to be able to be a part of that ecosystem in general. And so on the first part, which is the open finance platform, so the basic infrastructure on which you can build dApps. We were looking at building Zilliqa as a platform. We were also working on, we have also been working on defining and designing a new smart contract language that we call Scilla, which is designed with safety in mind. So there are many bugs and vulnerabilities that you see right now in the Solidity space, in the Ethereum space. You won't be able to write some of those buggy contracts in Scilla, which is the language that we use. The second is, as I mentioned, the strategic products. So we have been working with many of our partners in Singapore and outside of Singapore to work on some very critical infrastructure and some very critical products that people can use. And those infrastructures are backed by Zilliqa as a platform. And in order to build out this ecosystem, we have been working on this idea called Zilhive, which is a program, an incubation program in some sort, that gives developers access to funding, that gives developer access to marketing and anything that they actually need to be able to develop their applications or tools or infrastructures that Zilliqa platform would need. So with this sort of three-pronged approach, we have been attacking this problem of bringing open finance applications on top of Zilliqa as a platform. So we are a team, with varied strengths. So we have people, several of them have PhDs in computer science. So many of us are experts in security and languages as well. So programming languages, I mean. And then we have people who have, who come from entrepreneurial backgrounds. So they have been working on developing and setting up businesses that can take the challenges of this real world. Our team is also very varied and distributed in some sense. So we have people sitting in India. We have Anton, for example, who's going to give a talk later today. He's based in Russia. We have Arnav, our developer evangelist, who is based in India. We have people in Copenhagen. So there are lots of people, this team is very, very distributed in some sense. And hence takes the spirit of blockchains, which is also distributed infrastructure. So let me start with the first, the three-pronged approach that I mentioned. One was the platform, the other one was to build open 5 products, and the third one was to build the ecosystem around all of that. So let me start with the first step, which is to be able to develop what I call the platform, so the base infrastructure layer on which everything will be built upon. So as I mentioned earlier, we have 2 key offerings on this layer, so on the platform layer. So one is the Zilliqa blockchain. So I mentioned earlier about the issues that the blockchain infrastructure was facing in the early stages when Ethereum was, ICOs, for example, were popular. We had issues with CryptoKitties, for example, which forced the Ethereum network to go congested. So transactions fees went high because the base layer was not able to process transactions that was needed from those applications. So we decided to build this infrastructure that we call Zilliqa blockchain today. And the main idea that we have implemented in the Zilliqa blockchain is this idea of sharding. So at a very high level and very basic level, Zilliqa, the idea of sharding basically means that instead of having, let's say a network of 10,000 nodes that will process every single transactions, you divide that network into smaller groups, let's say 100 or let's say 1,000 nodes in each group, so that each group can process transactions parallel to the other 10 groups. And what happens as a result is that you can, once you're able to divide that network and you're able to process transactions parallel, so the more groups, smaller groups you have, the more transactions you can process. So on the right, we have this figure that shows these are real numbers that we observed on our internal testnet, private testnet that we ran a few months ago. So when you have, for example, a network of 1,800 nodes, which is equivalent to 3 shards, we saw that we could process around 1,200 transactions per second. And the moment you go from, let's say, 1,800 to 3,600, which is roughly, let's say, double the network size, you would see that the throughput also doubles. So from 1,200 transactions per second, you move to around 2,400 transactions per second. So this idea of sharding has become very popular in the last 1.5 years, I would say, and there are a lot of other chains that are now implementing and trying out this idea of sharding. But I'm very happy to say that we are the first ones to try it out and show to the entire community that you can use sharding as a scalability solution for blockchains. So this is the first offering at the platform layer. The second, as I mentioned earlier, is this idea of smart contract. So back then, we are seeing attacks happening on smart contracts. So we had seen issues with the DAO contract. So we had this very famous DAO contract, which was holding a substantial number of ether, and someone was able to hack that contract, was able to steal some money, substantial amount of money from that contract. And as a result, you had this. Today we have Ethereum and Ethereum Classic. And a bunch of other incidents happened after that. We had this issue with a parity contract, where you had a contract where someone is able to kill a dependency in that contract. And because of that, this entire contract just became useless. So people who had money in that contract, they could actually see that their money was there in the contract, but they could not withdraw money from that contract. So many of those incidents have kept happening. Even recently, for example, we had issues with exchanges. For example, Uniswap, which is a decentralized exchange contract, it had an issue with a contract called IMBT token contract. So the reason why some of these incidents keep happening or have happened in the past is mostly because the language was mostly designed from the perspective of usability. So how expressive a language is, how expressive a smart contract language is. So the more expressive the language becomes, the more easier it becomes to write and develop dApps in that language. However, there's a clear trade-off between how expressive your language can be and how tractable it is. By tractability, I mean the ability for you to be able to say that my contract is going to do this and is not going to do this. So be able to reason about the correctness and safety of your contract. So the more expressive your language is, the more complicated it becomes for you to reason about your contract. So we kept that, we had this idea that in order to make sure that your language is safe, you need to somewhat sacrifice in the way, in terms of how your language is presented to developers. So we had to fortify our language, which is Scilla, to make sure that some of the bugs that you see today in smart contracts cannot happen in Scilla. And also, on top of that, you want something more powerful. So we designed Scilla as a language that allows, or is very amenable to formal verification. So for example, you could take your contract and you could say, here is a property that I would like to verify. I would like my contract to have this property. For example, let's say if a contract has a certain number of tokens, then you want to make sure that this contract doesn't leak those funds to outsiders. Or if you want to transfer money from that contract to someone else, then the money only goes to the intended recipient. So many of these properties need to be verified. You want to make sure you as a user and also potentially you as a developer would like to make sure that the contract verifies these properties. So Scilla is built with that in mind. So you can, it's rather straightforward, for example, compared to other languages, smart contract languages like Solidity. It's much easier for you to write those properties and be able to verify those properties. By verification, I mean you could be able to provide a formal guarantee, a formal proof that your contract behaves in a certain way, or is going to behave in a certain way. So we'll have a separate session on how this language looks like, and you'll be able to play around with the language as well. So you might be wondering, how Zilliqa is different from many other chains out there. So obviously, if you look at Ethereum, which is the state-of-the-art chain right now, the Zilliqa chain can process at least 10 times more than what Ethereum can process today. So in terms of throughput. One key difference is also around what I call the consensus algorithm. So most of the state-of-the-art chains, or the chains that you are most familiar with, like Ethereum and Bitcoin, they use this consensus protocol called Nakamoto, which basically means that it uses some kind of a proof of work mechanism to be able to verify and produce new blocks. And one of the problems with this Nakamoto protocol is that it's probabilistic. So when miners are producing a new block, there's no guarantee that that new block will be accepted by everyone. So you have to wait for a few number of blocks to be mined on top of the block that you have seen to make sure that to have enough confidence that that block is going to be final. However, compared to that, we're using something called PBFT, which is short for Practical Byzantine Fault Tolerance Protocol. And with that protocol, which is a very classical protocol designed by the academics in the 1980s, I think. And so the one key idea of this PBFT protocol is that it gives you finality. So once a new block is mined, you can be confident and be assured that this block will not be removed from the main chain. So this will always be a part of the canonical chain. And with this finality, you don't have to wait for 5 or 6. For example, in Bitcoin, you have to wait for quite a few number of blocks that can take up to an hour, for example, for you to have enough confidence that your block is the final block. So in terms of, if you compare the decentralization level, so we are not quite there compared to, for example, Ethereum. So we have, for example, a network of 2,400 nodes, while Ethereum is around close to 7,000 to 10,000 nodes help run that infrastructure. But compared to many of the other chains that are coming up, sort of the second or third generation chains, for example, the Tezos or others, the number of nodes that we have in our network is much, much larger, at around 10 times or sometimes even more compared to many other chains that are out there right now. In terms of, latency, I mentioned that, there's a finality, so you don't have to wait for new blocks to be mined. We also have the Zilliqa also supports transaction fees, which are much lower. For example, if you're familiar with right now with Ethereum, fees are going pretty crazy right now on the Ethereum chain, mostly because of the fact that there are these DeFi protocols which are becoming popular, and then you have the network is being congested, so you have to push a higher transaction fee to make sure that your transaction actually gets processed by the network. So compared to that, because our Zilliqa's chain is scalable, you don't have that issue right now. So currently the processing fees is very, very low compared to Ethereum. As I mentioned, many of our team members are from academia. So we have also been very rigorous in our approach to research and development. So, for example, we have published quite a few papers on what we're doing with Zilliqa. So a very quick view of our roadmap. So we are working on obviously to improving. So we have developed this Zilliqa mainnet, which has been live for more than a year now. And now we are at a stage where what we are doing is to make sure that we can improve upon what we have already built. So there are quite a few projects on making sure that we can optimize what we have built, reduce, for example, latency, improve throughput, making sure that Scilla as a language is more easier for people to write contracts in. I will give you a very quick overview of what we are doing with our products. So we are basically working on two very key products right now. One is what we call stablecoins. So for those who are not familiar with stablecoins, stablecoin, so for any crypto asset that you see right now, for example, Zilliqa, it's a very volatile asset, so you cannot use it for payments. However, if you could build an asset that's sort of pegged to USD or pegged to Singapore dollars, for example, then you have an asset that you can use for payments. So we have been working with an entity in Singapore called Xverse. And with them, we have been working on developing this stablecoin product that's called XHD, so Singapore dollar backed stablecoin. And the idea is that this stablecoin is one-to-one pegged by Singapore dollars, and it will allow people to potentially use this asset as a payment currency, because it will be backed by Singapore dollars one-to-one, so you don't have to worry about volatility that you see with other assets. We are also planning to extend this to Indonesian rupiah-backed stablecoin. So you will have one stablecoin in Singapore and the other one in Indonesia. And then you can even imagine, for example, a remittance service between the two countries that uses these stablecoins as an underlying layer in some sense. The other product that we have been working on is the security tokens. So, for example, if you are familiar with the private equity space, there are a lot of companies which would like to take investments. However, the market is so closed that it's very hard for investors to get access to that asset class. So the idea for security tokens, for example, would be to tokenize the private equities of companies and then issue those tokens on a blockchain and then provide that. Give people, anyone, have access to that token. So it provides the liquidity and exposure to that private equity market. That's very clearly right now, it sort of runs behind the scenes. So it's very difficult for people to buy those private equities because you have to be in those closed circles to be able to identify that this company is looking for investment, so this company is looking for to sell its assets or shares. So the idea with security tokens is to be able to tokenize private equities, real estate, for example, or even let's say paintings, for example. So if you are looking for to buy paintings, or let's say Picasso, and you don't have access to that, then if that token was, if that painting were tokenized, then it would be much easier for you to get access to that tokenized asset and be able to buy that asset. So there are a lot of things that needs to be worked on this, and we have, for example, been working with this entity called Edge Exchange. So it's an exchange that has been licensed by MAS, which is the regulatory authority in Singapore, to be able to operate a security exchange platform together with Zilliqa. So Zilliqa is the base layer on which these tokens will be issued. A very quick overview of what we have been building on the ecosystem front. So this is sort of a very quick summary of what the ecosystem looks like. So we have been working with, for example, a bunch of exchanges to be able to list the token. We have been working with, as I mentioned, on the right phone, we have exchange like Edge Exchange, a product that we are working with this company to be able to issue and provide a marketplace for security tokens. We have been working with Xpers. We've also been working with this entity called Elliptic, which provides blockchain analysis tools to anyone who's interested in knowing if there's any illegal activity or illicit activity happening on the chain. We have tons of wallet management services that you can imagine that have been running on top of that are built around the Zilliqa chain. So it's a vibrant ecosystem growing every single day and capturing every single corner that people would like to make use of. So for those who are interested in becoming a part of this ecosystem, I would encourage you to check out our program called Zilhive, which is zilhive.org. It's a program, incubation program to help and encourage people who are interested in getting and becoming a part of this ecosystem and contributing back to it. So it provides people with funding, it provides people with any marketing support they can imagine, and any business support as well, if you would like to get connected to the network of people who are involved in the space in general. So with that, thank you very much. I can take a few more questions, if you still have time. Okay, so okay. Okay, I don't think I have any question. Developer tool like Zilliqa Explorer. Okay, so there's a question on what are the developer tools like Zilliqa Explorer. So we have several tools that we have been working on. So for example, people who would like to, let's say, develop a contract. So the first thing that they would need is an IDE where they can write and their code and be able to test that code. So we have a tool called Savant IDE, which is a web-based IDE. So it runs in your browser and you'll be able to very quickly write your contract and test it. We have, for example, SDKs. For example, once you have your contract ready, you want to be able to deploy this contract on the on the main net, and then be able to interact with that contract. So you need SDKs to be able to do that. So we have, Arnav is later going to show you some of that, but we have JavaScript SDK, which allows you to develop web dApps. So these are SDKs that allows you to interact with the contract that's sitting on the mainnet. You mentioned about Zilliqa Explorer. So we have a view block, which is an Explorer developed by a third party called Ashcloud. So they are a part of the community and they are running and maintaining this Explorer. We have also developed our internal Explorer as well that you'll be able to use very soon. So the second question is about what are the current dApps that are available to download? So there are quite a few dApps that you can use. So we have a few games. One is called Zilliqa Planet, a game that uses NFTs as in-game assets that you can check to be able to use and play around with that. So we have two games right now. One is Zilliqa Planet and Ocean Rumble. Both basically use in-game NFTs to be able to, for people to trade and use that. We have also another app called Unstoppable Domains. So it's an app that basically, so if you're familiar with ENS, where once you have, let's say, an account address, which is basically 0x1b25, so you could replace that account address, which is hexadecimal, and you could replace that by human readable account name, for example, amrit.zil. And then, so it's basically a domain registry contract that sits on Zilliqa chain. And you can use that, for example, to build your website, and you can put your website on IPFS and then connect it with a human readable name, so you could access that. So we have this unstoppable domain contract as well. We will use very soon. You'll be able to use XSGD, which is the Singapore dollar-backed stablecoin. A DEX is also very soon to go live. So you will have a Uniswap-like contract that you can make use of. So you can list tokens there and be able to provide liquidity, and also, by the way, earn some fees from that. And you know, that's also a possibility.
Amrit, can you click on Q&A?
I also, sorry?
Can you click on Q&A section?
Yeah, I'm going to that as well. Yeah.
Okay.
So what role does Zilliqa play in Project Ubin? So we were involved in Project Ubin, I think phase 2. It was then when MAS and Project Ubin were looking at building a settlement layer by using the blockchain infrastructure. So we have been involved in the very early stages of Ubin. After that, I think in the last phase, which was Project Ubin number 5, one of our sister companies, Achilles, was involved in it because in that phase, it was not just about blockchain for finance, but it had a much broader scope, where they were also looking at how blockchains could be helpful in the advertising space. And Achilles, which is the sister company, was involved in that phase. What wallets is available for me to use to stake ZILs? So right now, the only way to stake ZILs is through exchanges. So we are working right now, and we have almost finished writing what we call the non-custodial version of the staking contract. So it will allow people to be able to stake directly through wallets. So we're expecting it to go live sometime around September, so Q3, roughly speaking. So with that, once that's live, you'll be able to stake through your wallets. For example, Moonlit, Zillit, and a bunch of other wallets like Atomic are interested in supporting a staking feature for Zilliqa. May I know what are the main differences in context between the Zilliqa Open Finance and the DeFi initiatives? So there's some confusion about what's the difference between OpFi or Open Finance and DeFi. I would say that it's very similar in some sense. The reason is because Open Finance sort of came before DeFi, decentralized finance. So Open Finance has been very popular in the traditional financial space. So for example, it actually started in UK, so where banking infrastructures was traditionally been very closed. So you had one bank which had all its data, or one insurance company had its all data, and they were never talking to each other. So this idea came through some of the regulators in the UK, where they wanted these banks to be somewhat interoperable. So for example, if you had an HSBC account, you wanted to check your balance in your Revolut account, for example, or if you had an insurance company, then it wanted to get access to some of your data on your bank account, for example. So this is where the idea of Open Finance came into play. And so basically the idea was to be able to build an interoperable or composable layer of applications and infrastructures and services that could talk to each other, that could compose in some sense. And that had been extended to DeFi right now, where you would like that to be backed by blockchains. So for example, right now you can issue stable coins, and those stable coins can be lent in a lending borrowing platform. And so many of those things are very similar. So I would say that the main key difference between some of the initiatives that you see in the DeFi space on Ethereum and us is that some of the work that we have been doing are going to be regulated. So for example, the Singapore-backed stablecoin is going to be regulated because it's being issued by X Funds, which is a regulated entity in Singapore. XGX, for example, is a security token exchange, and it's being regulated by MAS. So that's, I would say, would be the key difference between what you see in the DeFi space in the Ethereum ecosystem and what you would be seeing on Zilliqa. Any plans for interoperability? So the answer is yes. We have recently announced the ability to bring BUSD, which is a USD-backed stablecoin supported by Binance or backed by Binance. That's mainly run on Ethereum chain. So we are going to build a bridge between Ethereum and Zilliqa that will allow people to lock Ethereum tokens, ERC20 tokens on Ethereum, and be able to issue a corresponding, what we maybe called wrapped version of those tokens on Zilliqa. And so it basically is a two-way bridge between Zilliqa and Ethereum. So yes, we are looking and working on that front as well. One question related to transaction cost. In Ethereum, we have gas for each transaction. What about Zilliqa blockchain? So yes, we have the notion of gas as well, so, and which is very similar to Ethereum space. So if you pay every time you allow people to send a transaction, whether a regular payment transaction or a smart contract transaction, you will have to pay a certain number of gas, which is roughly proportional to how much work is required by miners to handle that transaction. So yeah, it's very similar. The only difference is that the price you would pay for a transaction is going to be much lower on Zilliqa compared to Ethereum. If I wanted to tokenize a digital publishing platform specific to a particular industry, what resources are available to me in terms of token economics? This seems to be one of the most daunting aspects of open finance to me. So the problem in the tokenization space right now is the moment you want to hit or tokenize anything that has value, regulators would like to make sure that it has certain checks and they have oversight over what you're building. So the biggest I would say, for example, if you're looking at tokenizing anything like real estate, the regulators would like to see how you're protecting your investors in some sense. So I'd say that would be the biggest challenge around that. I don't think token economics would be the main hurdle there. How can I verify a contract that I wrote? I tested with several other tools to be certain I did not oversee something. So what we're trying to do, and Anton has a talk later on today where he would show you some examples of what property-based testing, for example, can do. So you would be able to write certain properties and be able to check through model checking on whether your contract is safe. So we are working on building some of those tools that would be easy to use for developers, because writing and doing all of that is not so easy unless you come from formal verification background. So we are also working with some external parties that we will be able to announce in the next few weeks, which one of those partners will also be helping us in building some infrastructure that will allow people to do property-based testing for their contracts. What are the challenges for exchanges to transfer ZIL to other wallets? I'm not sure if I understand the question, but if you have your token sitting on exchange and if you want to transfer it to any wallet you want, you basically have to create a wallet on that you have to create a wallet address from that wallet and then put it on the exchange withdraw field, and then you'd be able to withdraw your tokens from that exchange to your wallet. When is Edgy Exchange listing private companies? So Edgy Exchange is already prepared to do this. They are they're handling some of the internal stuff right now, but in terms of technical preparedness, they're prepared to list any company that they think would make sense for investors to be involved in. Yes, so there's a question about the price of Zilliqa and how it can impact the ZIL gas price. So there are some mechanisms on. So it's a very interesting question, but I would like to take it in a sort of slightly more general way, where in Ethereum right now, when the miners are the ones basically who decide the price, it's sort of free market where one miner comes out and says, I'm willing to accept a gas price of certain value, and then someone else who thinks that this other miner is charging for more, then they could lower that price to a certain lower value. In Zilliqa, the way we are doing it is to have, so this sort of model doesn't work and cannot work in Zilliqa because of this BFT protocol. So what we have to do is to make sure that all the miners that are sitting on working on Zilliqa, on the Zilliqa chain, are somehow have the same idea on what would be the minimum that they would accept. So they should all agree on a global minimum value that they should accept, the global minimum value of the gas price that they would accept. So what we're trying to do right now with what we have done so far with Zilliqa is that there is an algorithm, a deterministic algorithm that runs on chain, and where there's an agreement, a deterministic agreement that gets run between all the nodes, and then they decide on the price, on the gas price. And for example, if let's say the blocks are full or the blocks are not full, then only you will have to, the gas price actually changes. Otherwise, it doesn't change. So I have 2 more minutes. I can take probably 2 more questions. There is a question on the other chat. Should we make a dApp similar to Adobe Sign? This way we can make smart contracts more viable. I've been in contact. So if you're looking for anything around, let's say, signing, I would say that digital signatures, I would say, is enough for you to have sort of attestation. The only thing that you need is that let's say when you have a document that you would like to sign, you could sign using digital signatures, but you would like to put some sort of a digest on the chain so that you make sure that there's a timestamp somehow involved, and also that that stays there for eternity. So yes, you could develop, and there are protocols that like open timestamp that allows people to timestamp a certain document and be able to put a digest of that on the chain. Hi, Amrit. In one of the slides, you mentioned oracles. Is that only planned, or how easy is it to integrate oracles or interact with Oracle services like Chainlink on Zilliqa as of now? So we have Chainlink is something that we have been working with. You can use it, but we are also working with another company, another Oracle service provider that uses what we call the SGX. So Intel-backed hardware-rooted trust module backed Oracle. So for example, when you ask for a price, for example, an external Oracle, then the data that you get from that Oracle is sort of confirmed by, and you get the guarantee that it's coming from that hardware, which is by definition secure. So I think this is where we can probably end. I'm probably running out of time. So yeah, thank you very much for all the questions. It was lovely being here, and hope you will enjoy the rest of the talk. Thank you.
Thank you, Amrit, for your talk. Any other questions? We'll try to answer them on the chat. So yeah, that's about it. If we also have our quiz, so I'll just share the link of the quiz on the Zoom chat, and you can also see it on the Eventbrite page. And just a reminder, you can get to earn some ZIL by answering correctly, and you'll also get a certificate, Zilliqa workshop certificate, if you give all the quizzes and get a score above 50%. Thank you. So we'll just take a break for now, and we'll join back in around 20 minutes. We'll join at 3 p.m. SGT, to be precise. Hello, everyone. We'll just start the next session, which will be about talking about Scilla. In the meantime, I'll just answer some questions on the chat. So, for people who are taking part in the quiz, um, if you need to earn a reward, you would need to submit your Zelle address. So, you can use Zillpay or Moonlit or many other wallets that we support. Um, and installation, some people are asking about the installation steps. So installation is actually very simple. uh, just like any other crypto wallet, the steps are similar. For and also the we have the certificate. uh, People who will be attending, they'll also get a certificate, and I'll just show you the how the certificate would look like. um, it will be a blockchain enabled certificate. It will be deployed on the blockchain basically, and you'll also have some design to it. So this is how the certificate would look like. Okay, so let's start with our next session, which will be talking about Scilla, and I'll give you a brief overview of Scilla, and then on the in the subsequent session, which will be taken by Anton, we'll be going deeper into Scilla. So Scilla is stands for it's a formally verifiable safe contract language, and it stands for Smart Contract Intermediate Level Language. That's the full form of Scilla. Um, this is just an overview on Zilliqa for people who missed Amrit's session. Amrit extensively talked about yeah, what we are doing, what's our roadmap, how did we get started. But essentially, Zilliqa is a high performant blockchain that uses sharding to scale linearly, which means that as the number of nodes in the network increase, the scalability actually increases. And it was a brainchild of many people from NUS and couple of other academics, entrepreneurs, and engineers. And we have over 70 project teams from over 20 countries that are currently building on top of Zilliqa. So how does Zilliqa compare with other chains? So this is how you can see that. Um, Sorry, I'll just check the chat to see if we have. Yeah. So this is how Zilliqa compares with other chains. Uh, the main the main criteria you need to look at is the transaction throughput, um, and our consensus is actually proof of work plus PBFT. Amit talked about that in the previous session as well. But essentially, this consensus allows us to have instant finality, which means that if a transaction is confirmed once on the chain, you don't need to wait for more time. Like for Bitcoin, it's recommended to wait for like three block confirmations before you can accept that, okay, there is no chance of a block getting reversed and your transaction getting rolled up. But in Zilliqa, once a transaction gets added to the chain, it's instant finality. Um, so an overview on Scilla. Scilla is it's a peer-reviewed and safe by design smart contract language. It uses functional design principles as seen in OCaml, and it allows it to be more friendly towards static checks and formal verification. Now, what is formal verification? How we can do that? That will be discussed later in the next session by Anton. Also, it is Scilla is non-Turing complete, so there's possibility of for formal methods as well, writing formal proofs because of its simplicity. And being non-Turing complete, there are people think that there will be many limitations, but you can almost write any smart contract that you see in Solidity currently in Scilla. And yeah, so that's not an issue as if you are a developer. So people ask why a new language, what were the problems with solidity. um, so I'll just share two briefly walk through two examples of solidity hacks. And yeah, why we decided to create a new language, that sort of these hacks sort of form an inspiration to create a new language. So underlying causes with solidity are, it's complex and there's a lot of expected versus unexpected behavior, and there's no formal verification in solidity. And the thing about smart contracts, just FYI, is that unlike traditional software, they can't be updated, and you have a gas mechanism to pay for computational costs. So, and like say, if you're building a Web 2.0 application, people usually have the mentality to uh, build fast and ship things and break things. And if there's an issue, they just update the software, and that's very simple to do. But in smart contracts, you can't do that. That's sort of like the value proposition of smart contracts, that it's run in a decentralized manner. Um, and yeah, so you can't update smart contracts once they're deployed. You can maybe make a new contract, deploy it to a new address, and you can say, okay, this one is now the new contract. But you can have some like upgrade mechanism, but still you can't update the initial contract. And the gas mechanism part of it is that people developers, they are paying gas for smart contracts. So um, if they write some buggy code and their contract keeps on running, there's a chance that their funds might get exhausted. Obviously, it's recommended for developers to first test this functionality on testnet, so that they don't encounter such issues when they are deploying on mainnet. But still, that's also one consideration. Also, smart contract holds millions of dollars, and they are running in a Byzantine environment, and it's like having a bounty on them. So every smart contract has a bounty, and if you can hack that contract and potentially gain access to the funds, you basically earn that bounty. So coming back to the DAO incident, which essentially was led to the fork in Ethereum and created uh, Ethereum and Ethereum Classic, two chains, and it's still quite controversial, and many people don't think that this should have happened. Um, but yeah, it did happen, and it was still early days in Ethereum, and overall ecosystem has definitely evolved after the hack, but still smart contracts hacks are still popular. um, and if you look at this function withdraw, this was essentially the DAO was that people DAO stands for decentralized autonomous organization. So people had the option to deposit funds to the DAO, and they'll make sort of like investments in a decentralized manner. It will be all community driven, and after making investments they can earn some reward. Like say if people invested in some token projects through the DAO, and the valuation of those token projects increased compared to ETH, they'll be able to withdraw more ETH. um, so this had it had this withdraw function, the DAO contract, and it essentially allowed people to withdraw their funds. Now the issue uh, with this function was like, if you look at this function on the left side, you see function reclaim, and essentially what it does, it checks the value. It, if person calls this, essentially message dot sender is the address that is calling it. So what it does, it does message dot sender dot call dot value, if you look at this line, and this transfers control to this contract. So if the person calling this contract, if calling the withdraw function was a normal user, there was no logic that would do anything, that when this transfer is happened, when this yeah, when the control of this contract is passed here. But if this contract was a smart contract, when this line of code is executed, the control actually passes to this contract, and it can do some malicious things then. And what it can do is, for example, it can just keep on calling this withdraw function again and again and try to deplete the funds in the DAO contract. And that's what essentially happened. The hacker called this, and he was able to call it again and again. And this method, when the value of the shares of the hacker in the DAO contract never went to zero. So he called it, he withdrew his funds, called it again, he withdrew his funds, and so on and so on. And the right way they should have written the contract would be that first they should have set the value of message.sender to be equal to zero. And actually, first they should have stored the value that needed to be transferred to the hacker in a variable. Like here, we use in the variable amount, if you see on the right side, and then set the value of funds of the hacker in the contract to be equal to zero, and then essentially transfer the amount to the hacker or to the person, whatever. But this didn't happen, and essentially the hacker was able to drain funds, and this led to almost, I think, $50 million worth of ETH was stolen, which at in today's times would be quite higher, maybe 10x or something like that, because the value of ETH was very less back then. And so yeah, it was a very large hack. Now, what how do we mitigate this issue in Scilla, right? That's what we started to discuss about. In Scilla, we we add this, the all the external calls to contracts or any other address happen at the end. So there's not the if say you are writing a function in Scilla, we call that a transition. All the external calls that are part of the uh, all the external calls that are part of the transition need to happen at the end. There's no way that you can write some logic in the transition, and then uh, uh, you write the logic, and then there's an external call in between, and then the logic continues. All the external calls happen in such a way that in a transition, first you have the logic, and then you use the send keyword. That's what we use to actually do external calls. So this DAO hack would actually have been prevented in Scilla at the language level itself. So as you can see on the right side, we have the code snippet of Scilla. Similarly, talking about the parity multisig hack, in the parity multisig hack, essentially a noob was able to set himself as the owner, and he actually, I think, accidentally deleted the contract. So because the owner had the option to kill the contract, and around $150 million worth of ether were locked because of this error. And so we have in this scenario, we had this init owner function, and people were able to call the init owner function and pass in this owner pass an address, and if you look at the owner in line number 2, address owner, and if you look at line number 3, which is the buggy line, the value of the this owner that gets changed if someone calls init owner. So that's what happened, and the noob was able to set a new owner, himself as the owner, and he accidentally deleted that. So in Scilla, there's actually a clean separation between libraries and a non-library contract, and also we have mutable and immutable variables. Um, like if people want to if people if you want to have some variables that you don't need to be changed, like an owner of a contract is something you don't want to change right after the contract is deployed. You don't so you can set immutable variables. Those immutable variables actually get set when the contract is getting deployed, and mutable variables can be changed after the contract is deployed as well. So in Scilla, we would have used the owner variable, and the this would not have had happened, because no one would have been able to change the owner. And so these are some Scilla design principles. There's separation between computation and communication. Uh, so every contract computation is implemented at a standalone atomic transition, and there's no involvement of third parties involving any other party. So say you have one logic, uh, like say this I'll explain this after, when we are looking at the contract code. I'll explain all these properties. But the third one is something which we talked about earlier with the DAO hack, which is that there's separation between invocation and chained contract calls. um, yeah, because every external function, every external call happens at the end of the function or transition, as we call in Scilla. So why are Scilla contracts safe to write? You can read these points. Basically, Scilla is peer reviewed. It identifies security risks. It is easier to write safe contracts, and you can mathematically verify the security of your contracts using formal verification. um, and yeah, these are some security features of Scilla. So Scilla automatically handles arithmetic underflows and overflows, and since it's for functional programming language, there's structured recursion instead of loops, which also makes formal verification easier and your code looks more readable. Now, I'll just actually walk through some of the concepts of Scilla, so that when Anton is going to present, he'll be able to, you'll have some context for his presentation, and some, basics of Scilla. So if you want to actually try out a contract and try to check if your code is working fine and deploy that contract, you can visit ide.zilliqa.com, like I'm doing right now, ide.zilliqa.com. And there are some sample contracts that you will find on the left side, and you can actually check them and play around with them. So in this case, I'm just looking at the hello world contract, and I'll try to explain some of these concepts via by looking at this hello world contract. So smart contract languages, um, they're deterministic and irrevocable, asynchronous in nature, and they are bound by network rules. So that's something you just need to have an idea on. And dApps versus regular dApps, the thing is that in normal like when you're building websites, full stack applications, you have the front end, you have your server code running, and you have your database. Now in dApps, the the blockchain acts both as a server and as a database. So essentially, when you are, say, running your own node, then or you're connecting to another node via some API, you are able to access data from the blockchain, and you're essentially able to call that node and get data from the blockchain. So you don't need a separate server and database for blockchain applications. Although in reality, when you are building, say, a game or any other full stack blockchain product, you'll be using you'll actually be having a server as well, because you won't be like using blockchain for everything. Say you are going to do user login, you'll use Google or Facebook or email login in that case. As I told you earlier, there are two types of variables: mutable and immutable variables. So if you look at this hello world contract, you'll see that this we have these this first line, which is just specifying the Scilla version, and then you have an import statement, and you have this library. So this is how actually the structure of a Scilla contract looks like. That we have this first we have the import statements, and we have this library part of the contract, which is essentially part of the code that doesn't change Scilla state. This is just code that you can use again and again. It's just logical code that you can use again and again inside your contract. And then you have the contract definition. So that's where we need to focus on right now. So you see this, the keyword is contract and the name is hello world. So that's the name of the contract, and here you define the parameters. So here we have here you define the immutable variable. So if you look at owner is an immutable variable of type byte string 20. So that essentially is the format. It's a data type in Scilla that is actually an address data type. So byte string 20 actually looks like this 0x type format. So when you're deploying that, this is the immutable variable. And if you this is where the contract sort of initialization finishes, and then you need to look at these fields. So these are actually immutable variables um, that are defined using this field keyword. And here, for example, we have welcome message, and welcome message is of type string, and the initial value of welcome message is empty. We haven't defined any value for it. So this is what are variables. As I mentioned, there are two types of variables: mutable and immutable variables. So the immutable variables, which is like the owner variable, it can't be changed. Yeah, I'll answer the questions at the end. But and the mutable variables are the ones that, yeah, they can be changed after the contract is deployed as well. And these are just two address formats on Zilliqa. So we have this batch32 format and base16 format. So this is how this looks like, and this is how this looks like. And actually, these are interchangeable. Like if I say I copy this address and I go to tools address converter and say this one is a base16 address, you see I get this base32 address. So these two addresses are interchangeable, and the reason we had to introduce these addresses is a long story, but essentially this is more readable for Zilliqa. And we had to swap some tokens from ERC20 to Zilliqa. So that's the reason why we have this format as well. And this actually prevents any confusion that, okay, which were ERC20 between ERC20 Zil and the mainnet Zil. Currently, we only have mainnet Zil after the swap was completed. So yeah, you can effectively use this address everywhere. Now coming to transitions, which form a really important part. So if I till here we covered the mutable variables, immutable variables, and now we have this transition. So transition, if we look at the hello world contract, we have two transitions: transition set hello and get hello. In sorry, I'll just in set hello transition, you see this, right? Message string. This is actually the transition parameter, and this is of type string. So there's very strict type checking in yeah, there's very strict type checking in Scilla. So you need to specify the data type of your parameters. And yeah, this is how the transition looks like. And essentially a transition is like a function, and in a normal say object oriented background environment. And transition are callable from the outside. So if we deploy this contract, we will be able to call this transition and pass in this argument. Also, we have procedures. So you can think of procedures as sort of like transitions, but which are not callable from the outside. So procedures are just some block of code that you can't call from the outside, but they can be reused, right? So you can write a procedure and you can use that uh, you can use that inside a transition. You can use that actually in multiple transitions. So that actually makes your code more readable and reusable. So that's what essentially procedures are. And this is how the syntax of transition and procedure is. So they all, yeah, use the keyword transition, and you need to end the transition using the end keyword. So normally when you're using a function, you have a, you use something like this. like you're using function, and or a name of the function, or say in say JavaScript background, you use something like this: let x equal to some function name, some parameters here, text or something. But and then you start this open bracket and you have a closing bracket. So this closing bracket is somewhat similar to an end. um, Also, we have expressions and statements. So expressions are just pure operations. You can think of it like, an example is something like this, in which we are setting this variable, not owner code, to be equal to an unsigned integer with value 1. This is just an expression. It doesn't, like, say, alter any contract state. Whereas, if we say look at, uh, yeah, if we look at, say, something like this, or yeah, this is just declaring the field variable. Yeah. Moving ahead, you can also see these examples. So expression is like, let one, this example that I showed you already. Then statement is something which in which you are storing fields or invoking procedures. So yeah, in the contract you can see, okay, we are storing fields here, and like here you can see we are like invoking some procedure. I'll come back to this matching, what does this how this works like, in just a moment. But just moving ahead, so we had talked about that you can talk to other contracts. So say you have this transition and you want to um, talk to another contract after this transition finishes. So we use messages for that. So and we use events for actually updating people if there's some updating blockchain nodes if there's some change with the contract. So like, say a transition is called and a state variable changes, a mutable variable changes, um, or there's an error thrown or something like that, then we use events for that, so that nodes can listen to these events. And if say you are building a dApp, you listen to those events and then you will update the front end accordingly. So an example of an event is like, in this example, essentially we are this hello world contract. How this works is, we have this welcome message mutable variable, and we use this set hello transition to set the value of this welcome message. So, and we use get hello to retrieve the value of this welcome message. So if you look at get hello, what we are doing is, we are getting the values of this welcome message, and we are storing that in a local variable that is local to this transition. And and then we are calling this event e, and e is defined here. So the events, how they're defined is, you first need to specify an event name. So event name can be anything. So here I've specified get hello, and then we define a message. So message, here is the value of the message that is going to be passed, right? Here we define some some properties that you need to send alongside the event. So yeah, that's how this event actually works. We define the event name and some properties of the event. So here one property is message, and the value of this message is equal to r, which is equal to the mutable variable welcome message. So that's how get hello works. Now coming back to match, right? We'll just look at set hello. In set hello, what we are doing is, we are passing this message variable, and this message variable has to have a data type of string. And what we check is, we use this built-in keyword to do some built-in operations that come inherently with Scilla. And we do use the eq, which means equal. So what this checks is, are these two terms, are they equal? So it checks, is the owner of the contract equal to the sender? So underscore sender, I was just going to come this to this again as well, but this essentially gives the value of the person who is calling this transition, the address of that person. So is owner actually can be would either be true if the value of owner and sender are equal, and it will be false if the value of owner and sender are not equal. So if and then we use this match keyword. So match is, you can think of it somewhat like switch in JavaScript or other programming languages. So what it does is it matches, so you do match is owner with, right? So what is owner, it will be either true or false, because that's how it's defined. And if it's false, then this line of code will get executed, and if it's true, then these lines of code will get executed. Now, if it's false, we will throw this event with the name set hello and the property of code and the value not owner code. So the value of not owner code is 1, so it will pick that up from above. And if the value, if it is true, uh, s- we'll actually update the value of welcome message to be equal to this message that is passed to the transition, and we will call the we will call this event again, and the code will be different. The code will be 2 instead of 1. So essentially what's happening is, we have this in this contract, we have this functionality that only the owner of the contract will be able to call set hello and change the value of the welcome message. So that's what essentially this block of code is doing. But yeah, I hope that this match, built-in events, these make sense to you. um, I think we have covered almost everything. I just need to show messages and maps. Only these two concepts are left, and they will be required in the next session as well. So we'll just quickly walk through them. So I'll show a contract that has example of these. So this is the ZRC2 contract. So I'll be coming back to this again in my next session, which is session number 4, in which we'll be building actually a ZRC2 wallet, which will be similar to an ERC20 wallet. But essentially, if you look here, you'll find that we have these maps, right? Can you see this? Like we have field balances map, byte string 20, unsigned integer, and so on. So map is something, if you're familiar with hash maps, it's sort of similar. That this data type in Scilla is sort of similar. Essentially, has a key value pair that you can use. So and the key can be string, integer, unsigned integer, or byte string 20. These are the possible values of the keys, and the value can be of any type. Okay. um, and this is actually an example of a map. So you look at this field backers. So this is the name of the map, and we are here, we are, as you would have seen in Scilla, we first define the variable name and then we define the data type. So you see the data type is map, and further the map has the type key as byte string 20, and the value will be unsigned integer. So it's like this for this example, you can think of it like the key is the addresses, all the user addresses, and unsigned integer, like the value is of type unsigned integer, and that will be all the numbers, the amount associated with those addresses. So this is actually taken from a crowdfunding contract. So like in a crowdfunding contract, you will have, see all the addresses who have donated, and the subsequent value they have donated, right? So you'll use this map, um, and we are setting the value o- of this map to be actually empty. So we are setting equal to empty, byte string 20, unsigned integer. So that's how you actually define a map. And there's some, these are on the right, you can see some um, useful methods that you can use for a map. Like you can check if something exists using exists keyword. So you can check if an address exists as a key in this, using this, and C will store the relevant value. You can set the value by using this keyword, backers, sender, amount, and you can delete an entry using this keyword. So that's how maps work. Um, and yeah, also errors, if you can throw errors as well, and they have this format. You use the throw keyword, and you first mention this exception property, and you enter some name, so that when, say, you are reading that error, you understand, okay, this error was thrown, this specific error was thrown. But we use the throw keyword. Yeah. Also, only thing left now is messages. So essentially, messages in a transition. If we are sending a message in a transition, uh, we use the send keyword, right? So coming back to the Scilla contract, um, let's find. Yeah. Okay. Let's look at, say, transfer method. Okay. Okay. Let's look at transfer from, or if we have transfer. Yeah. So here, you transfer method basically allows people to transfer funds, and you can specify, using this transition. You can use to and amount. So to here refers to the address you want to send the funds to, and amount is the required amount you want to send them to. And it checks if it calls this procedure, and checks if the person has the relevant amount, and then you can send the then you can send messages as well. So, like, say, for this example, if say you want to send a message to the recipient, right, that the that you need to send the amount to the recipient as well, right? So what you'll do is you specify this tag, which is essentially specifies what message you are calling on. Again, when you're reading from the event, you will be able to see that, okay, this message was called, when you're looking through the blockchain events. And you specify the recipient and amount and sender and things like that. um, and after Yeah, and if you look at this variable, this is what is getting sent, right? Send messages, and messages has three, you append three things. So one is this two messages, message to sender and message to recipient. So these two come from here, and this two messages actually comes from the library part of the code. And this is a standard way that we use to define a message. This is a way to define if you want to send two messages. So here we want to send two messages, one to the sender, one to the recipient. And if you want to send one message, we use this format. You can just check this out by going to the IDE. So that's how actually we use messages. And just to show you how actually you'll deploy a contract. So currently I'm on testnet, and I have this address. I'll first check if my contract code is working fine. So you'll see, okay, my Scilla checker shows no error. And then I'll click on deploy, and I'll specify the owner. Sorry, I'll just remove this transfer. Um, I'll just copy my own address, and I'll specify my owner. I'll enter my passphrase, which was used when I actually imported my account. And you see, okay, the transaction is now been sent to the blockchain and is now waiting to get mined. So that's how simple it is to actually deploy a contract on Scilla. And like, say, if I make some changes here, say I remove this S, and if I now click on check, you'll see that the Scilla checker actually picked up the error in the IDE itself. So yeah, that's how this is just some an overview on Scilla and some basic functionality on Scilla. So essentially, I'll just to recap what we covered. um, on the properties of Scilla. We looked at variables, mutable, immutable variables, address formats in Zilliqa, what are transitions, procedures, um, expressions and statements, events and messages. So events are used to are emitted so that people can listen to the chain, and they can see if any changes are being made to the contract, and they can accordingly update the UI. And messages are used if you want to do external calls. Say you want to talk to another contract, or you want to talk to a user address. Uh, and we also covered error handling, so we use exceptions for that. I'll again walk through this in my last session and show you the example code or ZRC2 wallet. So this will solidify. And also we covered maps, which are essentially a very important data structure in programming. And it basically, it's a key value store, and you can only have certain keys and certain values in maps. So yeah, that was about it. If you want to if you have any questions, I'll just answer them after this session. I'll also post the link to the quiz of this session, which you can complete to earn some Zill, and subsequently you'll get a certificate as well. So yeah, I'll just now answer questions. If you have any questions, please ask in the Q&A section. That will be more preferred. um, so one question is, would I like to clarify the field parameters? What is it for? um, Yeah, these are actually the mutable variables. These variables are, sorry. These variables are part of the yeah, state of the contract, and we will use them to yes, they're part of the state of the contract, and they are used in various transitions to store important things in the contract. Why does Scilla seem so unintuitive as compared to other languages? I would say it's a bit unintuitive because of two reasons. One is that it's functional programming language, so most people actually don't have experience using functional programming languages. They have experience working on like object-oriented programming languages like Java. Um, JavaScript is also sort of object-oriented with the newer version. Uh, and yeah, a couple of other object oriented languages. So that's why it does seem a bit unintuitive. And second is that since it was designed in such a way that it is very difficult for you to make errors, the syntax is a bit like it does seem a little bit difficult for some people. um yeah, so that I would say these two are the reasons why it looks a bit unintuitive compared to other languages. But I think it's designed in such a way, and you have to remember that smart contracts, like you you have to make smart contracts very safe, right? Like if you are a programmer and if say you have $10 million worth of your user assets, or say $100 million in your contract, you don't want to fear that you would have written some buggy line of code, right? So um yeah, that's you just want to you want to sleep good at night. So yeah, that's why we designed in such a way that it's very difficult for you to make errors, and it feels a bit unintuitive because of that. Question is, which node do you use in deploying contracts from the new 7th IDE? We use our own nodes. I think in our, as far as I remember, when using new 7th IDE. Yeah, you can actually use our own nodes using our API service. So you can visit api.docs.zilliqa.com to actually uh yeah, to actually do that. So yeah, we don't have an option for people to connect their own like nodes in the IDE. What does Turing complete mean? Turing complete means that you can almost write any logic that you feel uh, in the contract itself. Like um, if you want to if you have some logic in mind, you can write it in that programming language. So that's what actually Turing complete means. um, and Yeah, so but in Scilla it's not Turing complete, but you'll be able to write almost all the, say, contracts you see on Solidity. You'll be able to write that. So that is actually not that much of a consideration. Yeah. Mm, let's see if I have any more questions. ID code editor cannot be scrolled with Chrome on Mac. Okay, I think you need to just refresh, and yeah, you'll be able to find it's working fine. I think we are also out of time. I'll answer the other questions by typing. So just keep them coming, and I'll answer them. I'll just take a break and give you time to actually complete the quiz as well. Um, and then the next session will be by Anton, who will go deeper into Scilla, and maybe some of your other questions will be answered in his session as well. Okay, thank you guys. I'll look at the chat and also I'll answer the questions there.
Okay, hello everyone, and welcome to my talk. I'm gonna be talking about the so-called Scilla tips and tricks. But first, before we go to that talk, let me briefly show you some cool resources that we have, because I already saw some questions in chat and Q&A. And so, for example, we have this Scilla docs on readthedocs.io, where you can basically read a book about Scilla and different chapters here. So definitely give it a try. And we also have Zilliqa reference contracts on GitHub. So that's open source, github.com Zilliqa/ZRC. So that's just a bunch of reference contracts you can check out to actually draw some inspirations from them and adhere to the standards we're trying to develop here. And let me also tell you that probably Arnav has told already that Zilliqa is open source. It's licensed under the GNU license. Okay, and now back to the talk. So, okay, hi again. My name is Anton Trunov. I'm from Zilliqa Research, and I'm on the Scilla team. So I'm one of the Scilla developers. So feel free to ask me any question. I'll be taking the questions after my talk. So, but let me quickly walk you through the plan of the talk. All right. First of all, we will be talking about the so-called safety idioms, and I already saw that on chat today. So, because your contract might be managing lots of money, so you definitely want your contract to be safe, right? And to achieve that, we have several features. One of them is a language feature called contract constraints. Then I will be talking about checking preconditions of transitions. Then we will be looking at a particular instance of that precondition. That's the deadline idiom. And then we will be talking about how to transfer money between your contracts. So the thing is, on Zilliqa, you can write several interacting contracts in Scilla. And so you might want to actually send some messages, some funds between those contracts. And so you should be sending money deltas and absolute values. And I will be talking about that in a moment. Next, we will be covering some performance tips and tricks. So I will remind you how to use maps in Scilla and what kind of different maps we have. And then we will be looking at this case study for how to get field map size. And at the last part of my talk, I will be talking about formal verification of Scilla contracts. So that this is my area of expertise. I'm developing a formal verification framework. So I will be giving you a sneak peek of that. So that's still work in progress. It's not been officially released, but we already have some promising results, which I'm eager to share with you. So we'll be looking at the so-called temporal properties. So properties related to time of one of the important contracts called crowdfunding contract, which is called like a hello world of blockchain contracts. And we will be looking at the tools through which we can do formal verification. So let's start with some safety properties and safety idioms. So this is the first one is called contract constraints. Let's say you have a multi-signature wallet contract. And I'll briefly explain what it means. So sometimes you want to collectively own some funds, right? So you might want to create this kind of multi-signature wallet, which will have owners list. So there can be like a bunch of people who collectively own some money, and they decide when to whom transfer those, right? And then you have some kind of limit called required signatures. So this is the number of required signatures. Maybe you want like 6 or 7 signatures if there are like 10 people collectively owning some money, right? But that means when you deploy this contract, so right now these are immutable contract parameters. These are not defined as of now. They will be defined when you deploy this contract. So you'll have to specify concrete values. And it's kind of easy to, screw up and put, for example, like an empty list here, or maybe if you have like 10 owners, then you can require 11 signatures, which means you probably just will freeze your funds forever, right? So to kind of circumvent this, you can put a Scilla expression over here. So we have this special syntax between with and double arrow. You put a Scilla expression, which is basically a Boolean, right? And you say something like, okay, number of required signatures is okay, which means it's within certain limits. So for example, you definitely want the required number of required signatures to be greater than 0, right? And you also want the same thing to be less than or equal to the length of the owner list, right? So that's the first one. And I'm skipping the exact expression because I think you got it already. And also it wouldn't fit into the slide, right? And then you also want to check that in the owners list, there are no duplicate owners. So there are no like copy paste mistakes or whatever, right? And then you basically check that these two conditions are true simultaneously, right? That's it. That's simple as that. That's just basically a very simple expression that the Zilliqa blockchain will check when you deploy this contract with some particular instances of this, the list of owners. And also, let me quickly remind you that this list of byte string 20 means basically a list of addresses. So byte string 20 is the type of Zilliqa blockchain addresses. And this unsigned integer of 32 bits width, so that's also common in certain languages. Right, next, let's look at the transition preconditions. So let's say you have a fungible token contract. So which means you basically want to implement your own currency on top of the Zilliqa blockchain. So you don't want to use these native ZILs, right? You use your own currency. And to actually create your own currency, you need to mint it, right? You need to create new coins. So you might want to add this transition called mint to your contract. So that's just part of the contract. Which allows you to give to this recipient, that's their address, right? This amount of your tokens, of your fungible tokens. But you probably already get it that this mint is kind of dangerous, right? Like not everyone can call it on the blockchain. So you want to check that only the owner of the contract can mint new coins. So to do that, we advise to use this idiom called, for example, isOwner. So this is basically a so-called precondition, right? It's something that must be true before you get to execute the rest of your transition, because otherwise it won't make any sense, right? So here's a procedure that does some authorized mint, but it works under the assumption that only the owner can call it, right? So here you can see that we can use procedures, which, as Arnav mentioned in his talk, like private transitions, right? So isOwner takes this address, which will be, of course, a sender, right? And checks that the sender and the contract owner are the same entity, right? So this built-in EQ is equality check, right? And so you match over this result if it's owner or not. So if it's not owner, you throw an exception, and the Scilla interpreter just basically aborts the execution. That's it. So this part won't be executed. And if it's true, if it's the owner, then you just do nothing, right? Because you can let the control flow to pass to the next stage. So that's it. That's a very simple thing. And in particular, we have this particular instance of the precondition idiom. We can check deadlines for transitions. So sometimes you need to add the so-called deadline parameter to your contract transition, because there is this thing called the transaction withholding attack. So the miners can actually try to postpone executing your transitions until the moment that is when they can take benefit of that. Okay, and so this is important for contracts operating with highly fluctuating prices, like some kind of token exchanges. And so what you do is you add, for example, this transition called buy until. So you can buy something until this deadline, right? And bnum is the block number. So it's basically like how people measure time on blockchain. Okay, and we use the same idiom, the precondition idiom. So if the deadline has not passed, then we do something. And what exactly, it depends on your business logic, so I'm not covering it here. So how would this procedure, deadline has not passed, would look like? So here it is. We have a special blockchain variable called block number in all caps, like screaming at you. And this is this peculiar syntax we use to read it. So there is a number of different arrows in Scilla. Sorry for that, but that's syntax. You have to pick something. Okay, so I can read the current block number. I call it current time here. And then I check if the deadline has expired or not using this built-in, which is called block less than, right? So if the deadline is less than current time, then it means that current time is greater than deadline. So if it expired, I just throw an exception, which means I won't be able to go over here, right, and do something malicious here. And if it's false, I also do nothing. And this is just the syntax for Scilla commands. So in principle, you can scratch that and just leave empty space here. Okay, moving on. So let's say you have several interacting contracts and you want to pass funds between them. So sometimes people pass absolute values. So they compute, so they have some kind of accounts map or accounts associative array. They compute the absolute values of the amount of funds a particular account hold, and they pass that. So that's not very safe. Because when you do that, you basically override account information with fresh value instead of making an incremental change, right? And I'll be explaining in a bit how it can be bad for a contract. So let's see how you can transfer funds the wrong way. So like, just to be a bit more concrete, let me use some Scilla syntax for that. So this is a Scilla message, right? So this MCG will hold some information. So this update means that I'm going to call the update transition, and that's the address I'm going to send it to, right? I just skipped a bunch of fields, message fields here. So I want to update account with this address with this new funds value, right? So that's the sender part, that's one contract. And let's say you have another contract, which is your recipient. So it will have the matching transition here and here. You see it's update, right? It will have these two fields, these two parameters, right? To and funds, just like here. And it will probably have some precondition, like some safety logic here, and maybe also some logic over here. But what's important here is that we just update the accounts map at this address with the new value of funds, right? And that's dangerous because it may lead to race conditions and also, for example, double spends, because there may be several transitions, several transition calls simultaneously, right? And you don't want them to kind of compete for this particular map cell, right? So Scilla is designed in a way so that these transitions are themselves like critical sections, right? So there is mutual exclusion here. You don't have to worry about someone like interjecting somewhere here, and so the DAO attack is not possible here. But there may be several pending transitions which may basically override the same value. So how do you do it instead? So it's basically like the same thing. You just have this message, but you treat the fields a bit differently, right? So instead of new amount, you pass so-called delta, right? Basically a change. So for example, here, you would call this update transition, and you would add some amount of funds. It's like when you transfer some funds on the blockchain without any contracts, right? You just transfer money, and that blockchain engine basically takes care of everything else, right? They update your balance with a new value. So how do you do that? You just read the accounts cell, right, into give it a name called old funds, and then you add this delta to old funds, right? And then you overwrite only after then, right? So you can immediately probably see that when you do several updates in parallel, they will be just adding more stuff to the same account. They won't be overwriting, right? And also there was a question on chat earlier about all these different syntax for like assignment. So this is basically saying, okay, old funds is a new name. So it's not a variable, right? It's not, you cannot change it. It's immutable. So here and here, you cannot change it. You just basically assign or give new names to these particular expressions, right? But this part is, yes, this is assignment. So here the field map accounts would be changed. And so this particular idiom, it avoids race conditions. Okay, and so we are talking about maps, and Arnav already covered them. So it's one of the most important data structures in Scilla. For example, you can use maps to represent user accounts, something like this, right? You have a field map accounts, you give it a type, you say this is a map, or in some languages it's called associative array or key value store. And that's a type from addresses, byte string 20 is a blockchain address, to the amount of funds this particular account holds, right? And you have to initialize every field account, every field variable or map. And here it says that's an empty map of byte string 20 to uint 128. And in Scilla, you have to explicitly specify all these types by hand because it's an intermediate level language. So it takes a bit longer to actually do stuff in it, but we're working on making it better for the end user, for the programmer. Okay, so we have two types of maps. One type is called field maps, which are mutable and they're very efficient. They are currently implemented as hash tables down below. And also we have immutable functional maps. They provide a lot of flexibility, but they may be less efficient because of some copying operations, but also you can use them in your libraries. So in the pure part of the language. Okay, so for example, we sometimes see people using this anti-pattern when they work with field maps. So what they do, let's say we have still our field accounts, just like on the previous slide. Okay, and you have this transition called update, or I could have called it foo, doesn't matter what the exact name here. So what they want to actually update some particular key of that map, right? They want to update some particular account. What they do is they use this syntax, and now you can see all three of different syntaxes in Scilla, how to access a variable or a map, or how to read from a variable, how to give some expression a new name. So let me explain it again, just in case, because I know that can be confusing. So this syntax, this backward arrow, that says, I'm just reading this value and giving this name to a value in a mutable field. So actually, at the level of implementation, you will be accessing the database here. So that's why it can be kind of expensive, right? So, and what this line does is it takes the accounts field map and it creates a copy of the whole map, right? And let's say your dApp is handling like a million of accounts. That will cost you some gas, right? So you can clearly see this part is clearly an anti-pattern, right? Now this syntax says, okay, new X name stands for this expression here. And this expression means that you put a new key into this map and or you change a certain key like that is already there in that map. The key is called ACK for account, right? And you update this key with this amount of funds in this map. Sorry if that sounds a bit confusing. I'm happy to clarify it afterward. And then so this creates a new copy of the whole map. So if you have like a million accounts in your map, this will sometimes create a new map with 1,000,001 keys. Now then, you also update the accounts map with this newly computed map. That's so in upshot, that's basically like 3 times will cost you around 3 times more gas, like proportional to the amount of the accounts in your map. Okay, so once more, this is just read a value from a field. That's just basically give a new name to this whole long string. You can think of it as a macro, for example, right? Like this is just a constant. And this means update a field variable. So these two pieces of syntax are to handle fields, mutable fields. Okay. So instead, people are encouraged to use this simple in-place operation on maps. So if you're handling field maps, you use this. This looks like array operation, array update operation in most languages. So it's just, I think it's familiar enough syntax. So please use that if you want to update your accounts. Okay, so one more thing. Sometimes people want to get the size of their maps, right? Sometimes they want to know how many accounts they have. But if you look in the Scilla docs, you won't find this operation for the field maps. So the maps that you can actually mutate, you can actually change, right? But they can find this built-in size operation, which lets them get a size of so-called functional maps. So they create a copy once more, just like we saw before. And then now they can get the size of the map, so they can know how many accounts they have. So that's also pretty expensive operation if you expect your dApp to be working with huge maps. If you want a lot of customers, right? So instead, you can use the so-called account size idiom. So you have this field map as before, and you create one more field variable, which you will be keeping the size of accounts in, right? This is a variable of type unsigned integer 32, and its initial value is 0, which is consistent with this empty map, right? Empty map has 0 key value associations. And if you want to get the size of this field map, right, you just read this variable, right? So that's the piece of Scilla syntax for reading from a field as before. Okay, but now we have a bit of a problem here, right? We need to make sure that the map and its size, they stay in sync. That's very important, right? And you have a couple of operations, couple of statements that may or may not modify the map size. For example, this one, this operation either changes this key to be associated with this value, or if this key is not in the map, it adds new key, right? So it looks like an array, but in fact it's not, right? Because it lets your maps grow or shrink, in this case, grow or shrink dynamically. Okay, so this might add a new key, so that might grow your account size, or might not actually do that, right? If you already have this account. Or the same thing goes for this. So if there is a key, it deletes. The delete operation, it deletes it. If there is no key like that, then it does nothing. So it's better to systematically use procedures instead, right? Because it's very easy to actually miss something and forget to update the map size. And so I will be showing you just one simple procedure. If I have time, let me walk you through that. Okay, so this procedure is to insert two accounts, right? So it inserts this key of this address type and associated with this value, right? So we check if there is already a key, named key in the accounts map, right? And if it's already there, we do nothing because we just update it. We don't change the size, right? I mean, we do nothing with respect to computing and updating the account size. And if it's not there, we just basically, we read the account size, we add 1 to it. So we add this constant 1. It's not shown here, but it's defined elsewhere. And we update the account size. And after that, we just reuse the same Scilla built-in for updating field maps. So that's it. Okay, so I'm running out of time, so let me switch to the formal verification of contracts part. So what is formal verification? And that's the topic that excites me the most. So formal verification is a family of techniques that help us to ensure our programs behave according to their specification, ensure that they are correct. So first of all, you need a specification, and moreover, you need a formal specification. So it's not just like something written in English or Chinese or any other informal language, natural language. You want to read it in some kind of logic, right? And also we need tools to connect specifications to our implementations, right? You can write your formal specification as some kind of logical formula, but then you have to somehow combine, like link them together, right? And doing that by hand is very tedious and not very reliable, to be honest. Okay, so let me show what we're going to do about that on this simple example. So let's say you have this crowdfunding contract. So that's a contract in the style of Kickstarter campaigns, and it has several parameters. It has the owner of the contract, right? The one who gets the money from the crowd, right? We have the deadline for the campaign. So that means if it's past the deadline and you get all the funds you needed, then you're okay to withdraw the funds from the contract, right? And go ahead and implement some cool stuff you were crowdfunding for. And also, of course, you have the goal, right? So that's the amount of money you actually want. And I remind you again that BNUM means block number. So that's like blockchain notion of time. And this is unsigned integer of 128 bits. That's how we keep, we count zeals, right? Or tokens with that. And you have like this accounts field map, right? But here it's called backers, right? And that's again the same map from addresses into the amount of funds each address donated, right? And so now in this fragment, I'm showing just the public interface to this contract. So we have a donate transition, which basically lets a backer to donate some money to the contract, right? And essentially what it does, it checks some preconditions here, which I'm not showing here because otherwise it won't fit into the slide, right? And when someone donates, we need to be sure that we record their donation here, right? So the sender, so the one who makes this transition, calls this transition, we record that they donated this kind of amount. So underscore sender and underscore amount, these are implicit parameters to each transition. Okay. Now we have the so-called get funds transition, which lets the owner of the contract to withdraw money. And also we have some preconditions, like it must be past the deadline and the goal must be met, right? Otherwise they're not allowed to withdraw money, right? And so this send instruction, send statement, it sends, I skipped a bunch of message fields from here. So, but that lets the owner to be the recipient, and then the amount will be all the money in the contract, accumulated in the contract. And also, since a campaign can fail, we must be sure that the backers can claim back their funds, right? So they can be refunded. And so that's kind of like the same thing here, right? Every backer can get their funds back, and not everyone else's, right? So what kind of temporal and safety properties can we specify, can we ask to be checked for, right? So for example, one of the important properties is that eventually contracts balance is always 0. So that means that we kind of like accumulate funds in the contract, right? And then at some point, after the deadline, Either the backers gradually withdraw all the money, or the contract owner can like withdraw all the funds in one go, right? Using the get funds transition. And then after that, nothing can happen, right? So the contract is dead and that's it. So what we check here is that everybody can withdraw money. Like the contract cannot freeze your funds, and that's an error you can see here and there on blockchain, right? Contracts freezing money. So we don't want this to happen. So we specify this as this. Eventually, contracts balance underscore balance is the amount of money contract, the amount of zills your contract holds. And luckily for us, we can express this thing in a temporal logic. So this reads like this. This reads as diamond, and this reads as box. And so box means always, and diamond means eventually, right? At some point in the future. So this formula reads balance is 0, right? So if I read this part, always balance is 0, which is clearly not true, right? It's not true that our balance is always 0 because people can donate, right? So the balance will increase. But this thing is true for the contract. So eventually, the contract wouldn't hold any money. So it won't freeze your funds, okay? Next, this property prevents us from forgetting to put the send instructions. So I showed you on one of the previous slides, the send instructions in the claim back and get funds transition. So these allow the backers to get a refund, or they allow the owner to actually get the money and proceed with their project, right? So that's very important that we don't forget to put any send instructions. And also, this prevents us from failing to record the donations into backers map. So if you don't record the donation for the backer, it won't also work. That might be a bit less intuitive, I think, but still you can check that. And so another property, temporal property, can be formulated as this: the contract always has enough money for refunds, or you can also say that the contract doesn't leak money, right? And this can be formulated in temporal logic like this. So this part is kind of technical. This is because when the owner gets the funds, they don't bother with cleaning all the backers map, right? Because that could cost that will for certain cost a lot of gas, right? So they just get the money and all the donations are there, still there, but no one can do anything, right? After that. So, but what's important here is this part. We are saying that, okay, so let's say we have all our backers, we get the sum of all the contributions for all the backers, and that sum should be less or equal to the balance, right? So we have always enough money, more than enough, right? Money to actually refund everybody. And what makes this property temporal, right, related to time, is this box. So this says always, at any point at execution, this is true. And here's the comment I already made. So how do we actually check that? We can use the model checking approach to actually do that. And unfortunately, I don't have enough time to actually go into the detail, but that's basically related to exploration of the whole state space of the contract. So any state your contract lined up with, we can check if the properties are violated or not. And so also let me quickly remark that those properties are not complete. So we have even more of them, right? I don't have enough time to go through all of them, and I don't want to bore you to death with that. So you can never know like if it's complete or not, but still, if you have enough interesting properties, that gives you high confidence in your contract. And so the specification, the properties I already showed you, they are written in TLA into language called TLA+. TLA+ stands for temporal logic of actions. Plus means plus set theory. This is developed by Leslie Lambert. So he is one of the fathers of the distributed systems research. So there is a tool in the TLA Plus toolbox called TLC Model Checker. So with that, we can explore all the states that we have. But how do we model check Scilla contracts, right? Because Scilla contracts are not written in TLA Plus, they are written in Scilla. So what do we do? And the answer is simple. We have a Scilla to TLA Plus transpiler, or you can call it translator or compiler, which is still work in progress, but we are showing you the preliminary results we're getting. So with that transpiler, you can translate the whole of your contract. So for example, this is just a fragment of the translation of crowdfunding contract that I showed you before. And you probably already see some familiar stuff here, maybe. Okay, so yeah, the rest is not that familiar. So this language is called TLA Plus, as already mentioned, and for example, we translate the Scilla match statement into this case expression because TLA Plus doesn't have pattern matching, but Scilla does. Also, we have to specify precisely which variables are changed and which are not. And here you can see this unchanged on all caps. That's TLA Plus syntax for the unchanged variables. And I'm not showing you like a pretty big expression over here, but here you can see that sometimes the balance and backers are not changed, right? And they are not changed in case if for example, it's after the deadline, right? We're not accepting any more donations. So the backers map and the balance cannot be changed. Okay, so you combine the transpile TLA Plus code with your temporal properties, like I showed you before, right? Like, for example, eventually always balance is 0, right? And you run the TLC model checker on this thing, on this combined thing. So for example, this is, we already have the crowdfunding contract. You can check out Scilla on readthedocs.io. If you check out that contract, then it's already correct. We are pretty sure about that. And this shows you here that there is no error. So this part says it's okay, totally okay. So that's a screenshot from TLA toolbox. But what would happen if, for example, we had missed accept statement in the contract? So if, what had happened if we missed to actually, so if we recorded the donation from some backer, but didn't really use the accept statement, which basically increases your balance. The contract without this accept statement does not do that. So when you run that in TLA Plus toolbox, you get this kind of thing. This one error, and here it says that invariant called no leaking funds is violated. So that means we have recorded that someone made the donation, but we failed to actually accept the donation, right? And moreover, this tool shows you the error trace. So you can actually trace the steps your contract is taking to actually reach this forbidden state. And this is really helpful. So with this error trace, you can easily debug your own contract. Okay, I think I've run out of time. So here are some useful Scilla resources. Please check them out. I showed them at the beginning of my talk. And let me just provide a quick summary. So here at Zilliqa, we take safety seriously. So we have an overall safer language design. So for example, inside transitions, you have like critical sections, right? You don't have to worry about reentrance bugs. We have safety language features like contract constraints that let you, that wouldn't let you deploy an inherently flawed contract. We catalog Scilla safety idioms, like we showed you already, right? We picked, for example, we picked this deadline idiom from some cool guys we're working with, our customers. I'm not sure if I can name them, sorry. And also we provide this formal verification framework to formally verify contracts. And thank you, and I will happily take your questions. Okay, I see a question on Q&A. It says, why do we need to copy a parameter account? Yeah, that's a great question. Actually, we usually don't need to copy it, right? So it was just an example of some anti-pattern we saw in some real world contracts that have been deployed on mainnet. Yeah, great. Thank you for question. Okay, let me open the chat here and check it out. Okay, here's one more question on Q&A. Can Scilla support data types like enums, structs, or interfaces? And I answered that live. Yeah, that's a great question also, thanks. We have user-defined ADTs. ADT stands for algebraic data type. So you can certainly have enum, that's basically you enumerate all the constructors you can have. And constructor here does not mean the same thing as in object-oriented programming, but yeah, that's definitely something you can do. Also, with the same thing with structs, because each constructor can hold several values in it, right? And as for interfaces, so sorry, I'm not Polish. I'm not sure what you mean by interfaces. If it's in the same thing, like for example, in Java interfaces, then the answer is probably no, because Scilla is an intermediate level language. So for that, we need a higher level language, which we're working on also, but that's a topic for a different talk. Thank you. Okay, Q&A. Question from Daniel Nege. I hope I pronounced the name correctly, sorry. Can you explain a bit more how to imagine race conditions and how does time progress on distributed system? And with this language, it's a bit difficult to imagine what is run where and when. Or when you think about the blockchain as a database, what kind of locks do we have, implicit or explicit? Okay, that's a really great question. So about locks, let me tell you this. So when you can have, for example, when you enter a transition, that's kind of like a lock. You acquire a lock, right? So no one can interject. No one can have interleaving instructions here. So you don't have to worry about your invariance here. And then you can call another contract, right? And then at some point after your transition ends, that contract will get your message, right? And it will start working. And then if there is any error in the pipeline here, right, then everything will be rolled back. So that's kind of like atomicity thing here. The time progresses, so that's, yeah, it's a bunch of questions, right? So the time progresses with your block number, right? As the blockchain adds more and more blocks, and if your user calls your transition, the user of your contract calls your transition, then you might actually see a new block number eventually, right? But you might be actually called in the same block several times, I believe. So race conditions, that's kind of a complicated thing to explain. I have a picture somewhere. I'm not sure I have time to actually find it, but you can actually imagine that if you have several execution paths, then they would actually be able at some point to compete for your transition, right? And if you just overwrite stuff, as I showed you previously, then you might actually, so if you're unlucky enough, you might get your map overwritten in some cases, let's say it like this. Okay, yeah, and here's a command that it's a bit difficult to imagine what is run where and when. Yeah, but mostly it's not a problem actually. So if you adhere to some safety idioms, that's fine. That's just probably basically don't overwrite stuff. That's it. Keep your invariants clean. Okay, I hope I answered that, but I'm happy to take more questions. Okay, let me answer one more question here on chat, and then we can go for a break. So the rent model is indeed a nice way of removing dead contracts. Wouldn't an owner-only variable like is dead also be an option without losing zeal in the process? Sorry, I'm not sure I'm following. Maybe Amrit, if you hear us, can you maybe chime in? Okay, great. Thank you everyone for joining, and I hope to see you all later. Thanks for the questions.
Thank you, Anton. Thank you for your time. Hello, everyone. Welcome to this session. Um, just let's wait for 1 or 2 minutes for other people to join. In the meantime, you can actually complete the quizzes of the previous sessions. You'll find the link on the Eventbrite page, and you can even find it on the Zoom chat. Just search for it. You'll find it: quiz 1, quiz 2, quiz 3, and we'll have a quiz for this session as well. Um, so I'll just start sharing my screen. So, just to give an overview on this talk, I'll be talking about everything except for, say, Scilla, right? Like, this talk is more geared towards people who are actually going to be, building front ends that will be interacting with the dApps. So, if you're a JavaScript developer, you should definitely watch this very closely. Um, because like writing smart contracts is only one part of the equation. You spend a lot of time actually working on front end, writing code that interacts with the blockchain, handling user account, like key management, um, d- using getting updates from the chain, like when a transaction goes through, and things like that. So um, we I'll just also like to share some important resources that you can use for the same. One is our API docs. So if you go to apidocs.zilliqa.com, you'll find some API documentation. You can use our API, and you can use our SDKs as well, uh, to interact with the blockchain. And also, we recently today launched our new dev portal. So our new dev portal basically has all the sections that you would need to actually get started. If you are getting started as a blockchain developer, if you want to learn the basics about blockchain, you can actually see that. If you are already familiar with that, you can directly jump on to developing on Zilliqa. There are some examples there. You can find some hello world examples, how you um, sections on how you'll do user key management, details on our SDKs, WebSocket servers, and things like that. So definitely check that out. So for this dev portal, the URL is dev.zilliqa.com, dev.zilliqa.com. And if you have any questions, you can definitely join our developer groups. The links are actually visible here as well on in the dev portal. Although you can, we also shared in the Zoom chat, so you can. We have our developer groups on Discord and Telegram. The Telegram group was recently started, um, but it's getting traction as well. Um, yeah. So in today's in this session, what I'm going to do is I'm going to show you a demo demo wallet that I've built, and that is a ZRC2 wallet. Now, what is ZRC2, right? ZRC is I'll not tell you because that's a quiz question, but ZRC is something you can just Google. It's like ERC, uh, and ZRC2 is similar to ERC20 format that we have in Ethereum. So Z- Zilliqa reference contract, and we have in this example, I'm going to be talking about ZRC2, which is a standard for fungible tokens. So I'm sure many of you are already familiar with what are fungible tokens. Like they are what drove the 2017 bull market to an extent, and we had the crazy ICO boom. ICOs was basically ERC20 tokens, and so in Zilliqa also we have a format. If you want to create such tokens, if you want to say have a community token, a utility token, if you have want to have say a stable coin, a DeFi token, you can do so by creating a fungible token. Uh, yeah, and you can do that on the IDE. You can deploy the token directly on the IDE. So like this is an you if you go to here, the IDE on the left side, you can see the sample contracts, right? So here you will see, for example, fungible token.Scilla. So this is the code for fungible token.Scilla, and you can actually just deploy the contract, and you just need to pass in some initialization parameters, and you'll be able to deploy the contract. So in this session, I'll show you this example. This is a ZRC2 wallet. It doesn't look like a wallet access because I this is a wallet developed by me, and I don't have great designing skills, but essentially it achieves the same functionality. It allows you to send tokens. You can send a ZRC2 token to another address, and you can see your balance of that ZRC2 token. So this is a very simple example. I'll also link this example, this GitHub repo, um, in the Zoom chat. So, and you can actually go to our dev portal as well and see the link. If you go to toolings for Web3, and it's an example in Zilliqa JS. So here again, I've explained this example in the dev portal. Uh, but yeah, so you can check that out. So that's cleared. So that's what we'll cover. We'll create this. I'll show you the code for this, and we'll go step by step and try to understand what's happening. And for similar, like if you're building another dApp, you can reference this for your application as well. So yeah, for our dev tools, if you missed our previous talk, we discussed about our IDE, which is a Scilla IDE, and it is, if you go to ide.zilliqa.com, you'll find that it has some functionality you can read on the slide. And yeah, so this, if we look at the Zilliqa JS library, which is the um, most used SDK, crypto SDK that allows for front end, interactions, or interacting with the blockchain using a programming language. This is the most used one. We also have Go Zilliqa, and couple of other SDKs. Java, we have a Java SDK, and these three are maintained by the core Zilliqa team as well, and the community. And these ones these are some SDKs that are maintained by only the community. So we have a Python, C Sharp, Swift, Ruby, and Dart SDKs as well. So this is some components of the Zilliqa JS SDK, and in this session we'll mostly be talking about the util component, the crypto component, and the blockchain component. So how does the interaction work? Like so when say you're building a front end of a dApp, what essentially is happening is you have this HTML, CSS, JS, or React, or whatever, or say you're using a yeah, you say you that's the code running in your website, and then you are talking to your backend. That's what usually happens. You'll be talking to your backend, and your backend would be actually talking with the smart contracts, and you'll also have a database, um, and maybe for user login, or some things that you don't need the blockchain for, like say if you want to have some reputation of the user, maybe you can use that blockchain as well there. But or yeah, maybe you need to store some images, and things like that, so you don't need to put that to the blockchain, right? um, so for those things, you'll have your database, and you'll also be talking to the blockchain. So to talk to the blockchain, you can either talk through your server, and you can also talk uh, through your front end. So on your server, say you have Node.js running, you can talk to the blockchain using Zilliqa JS, and get some information, or put a transaction, and things like that. Similarly, on the front end, if say you want to allow the user to directly you know talk to the blockchain, like say send a transaction, you can have a component of Zilliqa JS there as well. So core is not this is now we'll go into the packages of Zilliqa JS. In this session, I'll be specifically talking about Zilliqa JS, because most of the developers are JavaScript developers. Although if you are, say, a Golang developer, and you want to talk to the get some data, put a transaction, call a contract, you can use you can use Argo SDK, but it will be very similar to how you'll interact with the Zilliqa JS SDK. Um, and yeah, core is sort of yeah, it core plus base. We are going to talk about these SDKs. You can see uh, when this is how you actually import the you this is how you use the you interact use the Zilliqa core, Zilliqa JS SDK in your code. So here we have, say, this object, or variable, in it's the same in JavaScript. We have Zilliqa, and we are requiring our repository. So essentially, to install Zilliqa JS, you just search for Zilliqa JS GitHub, and you'll find all the installation steps there. Or definitely you can go to our dev portal, and see, go to Zilliqa JS and see source code and like installation steps here as well. But essentially, this is the installation steps for Zilliqa JS. You can use Yarn. We recommend to use Yarn for installing. And once you're done with that, then you can actually start playing with the code. So then you'll require the module, and here we are using the util submodule within Zilliqa JS, and we are requiring these methods from the util module. And similarly, we create the Zilliqa object. So this is very vital. We always need to create the Zilliqa object to actually talk to the blockchain. And we create the we use this syntax, new Zilliqa, which was obtained from here, and we pass in our the API URL. So if say you are working on testnet, so you'll use this URL. So and say if you are working on the mainnet, um, yeah. So if you are on the testnet, developer testnet, you'll use this URL. If you're on the mainnet, you'll use this URL. And yeah, we have the other URLs for other things as well. Um, and now let's actually look at the code, right? So these are some slides, we can cover them, but I really want to give you a thorough understanding of what's happening. So in the code, again, you can see these things I've written. We have Zilliqa uh, imported from here, from the Zilliqa JS module, and we created a new Zilliqa object using the syntax, and we are also using Zilliqa util. Now, in our wallet, what essentially is happening is sorry. In our wallet, what essentially is happening is we are receiving, we allow the user to add a token contract address. So the user adds the address of the token, of the CRC2 token that maybe he deployed or someone else deployed. And then we also allow user to log in with their key store file. So I'm sure you would have seen this key store login, which is basically a JSON file that you upload, and you pass in your password that decrypts that file. And from there on in, you can actually start calling your contract, because you can gain access to your private key. So we are doing a similar login flow. And when a user uploads the keystore file, we fetch the token balance of the user that is visible on this zrc2 contract, and we also fetch the Zilliqa balance of the user. And so this is all the fetching part of the code that is happening. And we also have an option that you can call the contract and send token to someone. So this is where we'll be covering that. So send token, sorry, send token will be this part. Will actually send token to someone who doesn't have any tokens. So or maybe has tokens as well. So that's the flow of this. Now, in if we look at the fungible token contract, we'll see that let's look at relevant functions in the fungible token contract. So essentially, we need to have two function look at two methods. One is to fetch the token balance, and second is to transfer token, right? So to fetch the token balance, you'll see that, okay, let's look at the transitions. So this is the transfer transition. So if you want to send the tokens, we'll use this transfer transition, and we are going to specify these two values to it. And in this example, since we are doing everything using JS, we'll not be actually interacting with the ID anyway. It's like how a user will interact. We'll send all these values through this code, through our JavaScript code. So yeah, so this is how transfer actually looks like. You can go to id.zilliqa.com and go to fungibletoken.scilla. There you will find actually this one. This is a contract that I created. It has some modifications, but look at this one, fungibletoken.scilla, the one in camel case. And to get the balance, we are actually storing the balance in a map, which I discussed in my second session. In the second session, and Anton also discussed maps in his session. But if you see this, we have this balances map, right? That we are using. And the balances map essentially is an empty map initially, and it the key of the map is a byte string 20, which is like a address data type, and the value is an unsigned integer. Um, and we define it empty. And actually, when we are initializing the contract, we put the values that are defined while initializing the contract in this map. So the contract owner can assign some um, balance to himself, right? So essentially, yeah. And if you go and deploy to this contract, you'll see something like this. You need to mention contract owner, the name of the contract, a symbol, decimal spaces that you need, and there's this concept of operators. So you'll have that as well. And you'll have initial supply that you need to that you want in the contract. And yeah, and that's about it. So imagine that I've already deployed that. So I actually just deployed this contract already. And if you look at this deployed contract, I also did some transactions. So if you look at the balances map, you'll see that I already have these addresses. And these addresses in this balances map, this is the byte string 20 address, and they have some value as well. So this address has like one. The balance of this address for this token is just one. This balance has 89,956, and so on and so forth. Okay, you can see this balance, and you can see the total supply of this contract as well. And this one, I just gave the symbol as USDT. Just it's just random. But yeah, and this one is deployed on the testnet. Okay, so this is cleared on the contract side of things, right? This session we'll not look at a lot on the Scilla side of things, just focusing on Zilliqa JS side of things. So if we go back to our example, I'll actually just share this in the chat if you want to follow along. Uh, so this you can clone this repo and go to look at app.js. Um, yeah, or just go to this link and click on app.js. That's the yeah, that's the one that I'm talking about right now. So I've shared the link on the chat as well. Yeah, if I'll zoom the code. I think this should be visible on. Yeah, I think this is fine. This would work fine. So this is the Zilliqa JS code. You can follow in the link as well. So as I already talked about, we discussed about importing and creating the Zilliqa object. Now let's look at, say, fetching Zilliqa balance, right? Let's look at that method. So if you're familiar with React, the first method that gets called is like component did mount and component will mount. Component did mount gets called when the component loads. So in this we have this, we're calling this dot fetch zil balance. Now what that's doing is okay, also yeah, so what this is doing is this is getting the user address which we got after we imported the key store file. So I'll come back to that a bit later. But we get the user address, we trim the initial 0x from the address, and we are calling this zilliqa.blockchain.getBalance. So this is the method that we're using to get user balance, and we are passing in this user address, right? And this returns something, right? So if they I think if something returns, then we go in this if condition, and we get the from the result we get balance state dot result dot balance. So you can actually go to api-docs.zilliqa.com, and if you go to blockchain sorry, account related methods, and you'll find get balance there. So you'll find this documentation there, and you can see that balance equal to await zilliqa.blockchain.get balance, right? So this is what the exact code that I'm using in my example. um, and the object that is returned, you'll also find this. So this is what the example response is. So you'll find that our the value that we need is actually here, right? And this value is in qa, which is like the smallest unit in Zilliqa, like similar to, I think, Way in Ether or Satoshi in Bitcoin. So we need to convert that to Zil, um, right? That's what we show in the balance. So that's what we are using here. On this line of code, units dot from qa, this is again just standard code that you need to follow. There's not any like logic behind why we are doing this. But if you look at this and if you look at units what was actually imported here. See this? Units was imported here using Zilliqa JS slash util. It was part of the util submodule of Zilliqa JS. And we used this to actually change the value from QA, which is the smallest unit in Zilliqa, to Zil. And that's about it. So that's so simple, right? We just need to call this and get the balance, and then we once we get the balance, we convert the balance to relevant amount in Zil. And yeah, we set the state of this variable, and accordingly the value here also gets changed, right? So here currently I have around 300 Zil as my balance. um, but that's just example of fetching Zil balance. Now let's look at, say, fetching token balance. So we have this fetch token balance function, and remember these are all asynchronous functions, right? So you would need to use something like async await or promises to work with these type of functions. But for fetching token balance, what we need is the token contract address, and we need the user address, right? We need to know which contract we need to look at, the and which user we want to fetch the balance of. So um, if you look here, we'll find that we have this local storage.get item. This is just, I'm just storing the token contract address. When someone enters this token contract, just storing it in my local storage currently. And from there, I call await Zilliqa.blockchain.get smart contract state. So again, this is again a blockchain method, like Zilliqa.blockchain method. And if you want to look at, similar um, contract methods, you just go to contract related methods here, you'll find that. So here what I'm calling is get smart contract state, because if you remember, in the fungible token contract, we had our balances map, and we need to get the state to be able to fetch the value of that mutable variable. So we get the state, and you see, we call this we find the balances map there. So if you go to get smart contract state here, you'll find that um, if you call smart contract state here, this is the example response that comes. Yeah. And and uh, and, and so so you need to um, the balances map, the state variables will be accessible using this syntax. This is just syntax that's how the response is, the format of the response is. So that's how it's coming out. So, and user address is, we just get it again from the local storage, um, and we convert it to lowercase because that's how it was stored in the map. And just this in case, like if someone didn't enter in the right format. And then we, after the map is retrieved, we just pass in the key as the user address, and we get the value of the user balance. And if the value is exists, we set the value as, if say the key of the user exists, right, we set the value, or as in the balances map. And if the key doesn't exist, we set the value as 0, because the user, there might be case doesn't have any token balance. So that's how you actually get token balance, right? So we covered these two parts in the contract. So see here, we have 300 and 9859. And if we go to the IDE and actually look at the state of the contract, you'll find, and we go to balances map, right? Um, and this is the user address 0x181 and 904. So 0x181, this one. You see, here we can see the same balance, 9859 and 9859. I'll send a transaction and show you that this will change as well. Um, but this is this, the examples I show you cover the part of fetching data, right? Now let's actually look at code we'll use to send tokens, right? And before that, let me just import, say, a different address to this wallet, and show you what happens then. You see, so in this address, it only has a Zilliqa balance of 0.999, and the token balance is 0. So this address doesn't exist in the balances map, and that's why it's coming to 0. Now let's go back to our original address that had the token balance. Yeah. So we got the token balance. Now let's actually try to send some tokens to another address. So here I'm using Zilpay. So Zilpay is a Chrome extension. It's very similar to MetaMask, right? So this is Zilpay and this is MetaMask. Yeah, think it's locked. Yeah, but it's quite similar to that. And you can use that to interact with dApps. So let's say I want to send some tokens to this address. Okay. So or maybe, yeah, let's say I want to send tokens to this address. I click on copy, I paste the address here, and I select an amount. Let's say I want to send it, say, 9. Its current balance is 9859, should be 9850. Okay, so it's now just clicking sending. It will take some time because of blockchain confirmation, and in the meantime we can actually look at the code that achieves this, right? So the function that achieves this is this send transaction function that we have. What it does initially is, this is just what I showed you, that when I click on the button, this changes to sending, and it gets the local storage, it gets the token contract address, it gets the private key, and yeah, this is just, it gets the this lines of code are just, getting the required data of the user and the contract, and the code actually starts from here. So if you look here, we'll find that Zilliqa.wallet.add by private key. So this is a way, Zilliqa.wallet is a module that you'll use to, push transactions to the chain, maybe contract transactions or some other transactions as well. Um, it's very commonly used. And here we use the add by private key. So we use this add by private key method, and we pass in our private key to this method. Um, and this actually loads our wallet to an extent. And these are again then some parameters that we need. So chain ID refers is 333, means this is a testnet chain, and some other parameters as well. Specify the gas price, um, and things like that. Now let's look at, say, line number 142, right? We have contract address dot substring 2. So just removing the initial 0x of the contract that we are sending the funds to. And we now let's look at this. So what we are doing here is, so in Zilliqa JS, you need to we use byte string 20 format, right? So the one that starts with 0x. So what we are doing right now is we're converting our recipient address um, to actually byte string 20 format, and we are using from batch 32, right? And if you go above, you'll find that from batch 32 address is actually part of Zilliqa JS / crypto. Okay, so this it's part of this module within Zilliqa JS, and most of these, signing and key related, account related methods you'll find in Zilliqa JS crypto. So here we do that. We add the smart contract address, and now let's look at this one. So Zilliqa.contracts.at. Now this actually sort of, you can say, adds the contract to this Zilliqa object, adds our contract to the Zilliqa object. And then after that is added, and this is stored in this variable contract, we call the contract by using contract.call. So we use that, and we pass in some parameters, right? So if you look at these parameters, you'll find this transfer. This parameter refers to the transition in the contract that we want to call. So when we are transferring the funds, we use the transfer transition, right? And here we are mentioning the parameters within the transition, right? So if you look, as I showed you earlier, if we look at the transfer transition, it has two parameters, right? To and amount. Now, if we go back to the code, you'll find that vname, which essentially means refers to the transaction name, is to, and this is amount, right? And this is the type, and this is the value. So the value of to is the recipient address that we got from here, and the amount is something which we got from here. So that's how, and we just pass in these conditions, these parameters as well that we are defined above, and that's about it. Um, that's all you need to do to call the contract, the transition in the contract. And here I'm just actually just consoling, logging the console, and getting some JSON of the transaction receipt. So if you want to say get a transaction ID, you can use this method. You want to see that when you are developing, you want to see the transaction ID and you want to look it up on the block explorer, you can do that, because that you get the transaction ID even before the transaction is actually mined. Um, and here I'm actually, after the transfer happens, this page actually reloads. So if you look at the balance now, the transaction actually got confirmed and the balance is now 9850, right? And this address would have actually gotten the balance. So we can actually verify this by going to the IDE. Um, Let me copy this, look at this address. So it is this, right? 0x4BA and BBEA. Okay, so let's look at this address in the IDE. Let's refresh the IDE once. Um, Essentially, we are looking at the ID, but we are essentially just looking at the state of the smart contract on the blockchain currently, right? So the address was 0xBA 4BA, something like that. Yeah. So you can see this address. This corresponds to the address that we sent the funds to. And you can see that it received 9 tokens, right? And our initial address like got deducted. Our 9 tokens got deducted from there. So yeah, that's how this worked. And so that's actually just covers our example. um, so we talked about how, just to recap, we talked about how you could fetch balance, how you can fetch token balance, fetch Zil balance, how you can actually call a contract using Zilliqa JS. So these 3 things were the ones that were covered in this talk. um, Also, just about to run out of time, but we discussed in Zilliqa JS, you can find ways to, if you go to the GitHub repo, to, if you want to actually deploy the contract, if you don't want to go to the ID itself, right? You don't want to, you want to do everything from your command line. You can actually deploy the contract using Zilliqa JS as well. Yeah, so one small thing that is left is WebSockets, which I'd like to cover. So like, imagine when you send this transaction, right? You need to get an update. When did the transaction actually get updated? um like, you want to get an update that the transaction got updated and you need to change the UI, right? So for that, and I'll just show you an example for this as well. So let's say I send this contract. Let me copy this address. Let's say I send, okay, need to use a different address format for this example. Um, I copied this address and let's say I send another Tenzil, right? So now it's going send and it's sending. Now, for you, what you want is, you want to update the UI as soon as the transaction gets mined, right? It gets added to the chain. So how would you do that? If say, yeah, how would you get updated with that? So let's just actually wait and see what happens to this example after this transaction gets mined. So it's just currently sending. We are using the Zilliqa testnet. So let's see how much time it takes to, for this transaction to get mined. In the meantime, I can also okay, it's getting mined. So you see this page got refreshed automatically. I didn't do anything. This page got refreshed and the balance got updated and the sending is not, doesn't exist anymore. So what, how did that happen, right? So for this, we are actually using the WebSockets. So if you look at this method in the example, event log subscription. So all these examples are, in synchronous on order. So if you are following this video, looking the, and if you're maybe later looking at the code, you're watching this video on YouTube, you can follow that very easily. So this event log subscription method gets called actually in component.mount itself, because we are constantly looking for if there are any updates, if there are any updates for Zilliqa balance or token balance. So essentially, this is how you to get updates. So we have this uses event clock subscription method, and currently I'm using this, and we build this object, and currently we support two types of subscriptions. One is a new block subscription, and one is subscription to a contract, so that you can see if any changes have happened in the contract, like say a transfer transition has been called, right? So what essentially happens is here, this we are in this part, we're just building this event log, and here we are looking for emits. So when the emit actually happens, when an event actually gets emitted, we call this dot fetch token balance again. Okay, so that's we what we are doing is we are looking currently for events to this contract address. You see this token contract address, and when the event gets emitted, we call this dot fetch token balance again, so that we can get the new updated token balance of the user. And again, documentation for this can be found on our dev portal. um, I think I closed. Oh, yeah. So if you go to Dev Portal, it's actually in toolings for Web3 section, and here you'll find WebSocket server, right? And you'll find that we support. Yeah, these are supported queries, new transaction log, event log, and there's also an option to unsubscribe. Say if you don't want to stay updated with what's happening, and yeah, then you can unsubscribe from the event log. But this is all for this example. I think we covered almost everything. uh, Fetching balances, sending transactions, updating the UI. And if you're building more complex dApps, you'll sort these are sort of the building blocks that you'll use for those dApps as well. So yeah, that's about it from my side. I'll be happy to answer any questions. We'll also share a quiz for this session. And again, just to repeat myself, if there are rewards around, I think $15 for 10 winners in this quiz. And we will be giving out certificates for people who do all the four quizzes, get 50%. And if you have any questions, by the way, you can join our groups. So we have our Discord group and our Telegram developer group. Again, you can find all those links in our dev portal. uh, Go to developer groups here, you'll find those links. um, yeah, that's about it from my side. Yeah, I'm just looking. If you have any questions, I'll be happy to answer. Oh yeah, okay, so one question is, can you do this using vanilla JS? You can potentially do it. I actually did try to do it, but I won't recommend it, to be honest. Like, um, you can, I did make an example that actually used simple vanilla JS to use all those functionality. But to be honest, you'll be using Node, right, to install, or Yarn to install the packages. And yeah, there were some issues with, like, say if you want to, there are many like um asynchronous functions that are part of the code. Then yeah, there were some roadblocks. I can't remember exactly, but I won't recommend to use actually vanilla JS. You can do it. I actually did try to do it, and the Zilliqa JS was working fine with vanilla JS as well. Yeah, you can do it. Yeah, and anyway, you can use Node.js, right? If you're building on the backend, you can use Node.js to do this. But yeah, vanilla JS itself, I think, doesn't support many functionalities that you would need to do all everything. You might need to use something like Node to achieve that. We also have Amrit and Anton back. Hello, guys. Okay, let's see. if we have any other questions. Yeah, it looks like there aren't any questions. But again, just feel free to reach out to us on our developer groups if you have any questions. Oh, let's see. Any plans for European adoption? Okay, so this is not a technical question, but definitely we have some of our team members in Netherlands and couple of other one person is in Romania, I think, and many of our community members are actually like Eastern Europe. If you go to Google trends.google.com, you'll find actually that many of our like the tops place where Zilliqa search is Eastern Europe. So I don't know why that is, but definitely we have some plans to do some meetups and workshops. One of our community members is planning to do that after COVID thing improves. Um, Also, personally, since I look at adoption, I'm talking to a couple of developer communities in Europe that we can host webinars and hackathons with. So yeah, any other ideas you have, I'm open to listen, to be honest. Okay, that sounds good. We are going to wrap this up for now. Thanks everyone for joining. For people who have completed the quizzes, you'll get your rewards, and we'll give you some blockchain deployed certificate as well. And yeah, hope you join us in building on Zilliqa, and you have some interesting applications. If you want to work on a larger project, you can apply to a grant on Zilhive. Also, we have Zillacracy, which is a Zilliqa initiative. And we also have a couple of we are also going to launch some Gitcoin bounties soon, so I highly recommend to join our developer group where we are going to share this, and even potentially we are launching our community call series as well with developers. So yeah, that's about it. Thank you guys. Bye bye.